We have used this approach. Producer sends message to the queue and consumer consume the message from the queue. It works fine for simple application. What if you have 1 million users or 100k users? It's not flexible for multiple users because you will not have one queue. You will not remember all of the queue name, right? So far we have sending messages directly to the queue. This works fine for small projects, but as your app grows, this design quickly becomes rigid and hard to scale. That is why Exchange comes. Exchange, if you have understood the scenario of post office, you send your document to post office, and post office is like Exchange. Post office identify the address in which location the document has to send or parcel has to send, or which city the parcel has to send. Exchange is doing the same thing. Producer sends message to the exchange. Exchange will figure out which is the appropriate queue, QA, QB, or QC. Producer publish a message to an exchange, not directly to the queue. Exchange routes messages to one or more queues. Routing rules are based on bindings and routing keys. An exchange is like a traffic controller for messages. Producer no longer send messages straight to the queue. They send them to the exchange. The exchange then decides which queue should receive which message. Here's a real world analogy. Post office sorting example. Producer, you and the post office is an exchange, and queues are the mailboxes, right? So exchange is like a post office. Routing key is your address details, your address label, and queue is mailbox for a specific recipient. Think of it like a post office. You drop your mail at the post office. It sorts each letter based on its address and sends it to the correct mailbox. The exchange does exactly that for messages. Here's a real world scenario. We're going to implement this Gmail notification. A user sends message. Actually, a new user signed up. We want to send 3 notification. Email team want to be notified, like you have to send the email notification, or maybe it could be SMS microservice or app service, push notification service. We want to send 3 notification: email, SMS, and app verifications. We cannot store all of them in one queue. That is why we created 3 queues: email queues, SMS queue, push notification queue. Single event triggers multiple actions. Exchange routes messages based on type. When a new Gmail user signs up, several services need to act. Like the email service sends the message a welcome message. The SMS service sends a verification text. The push service sends the app notification. Instead of managing 3 separate calls like send to email queue, send to SMS queue, send to push queue, that is the manual approach. You just publish an event to RabbitMQ and give it to the exchange, then exchange route your message. How it works? We're gonna create notification exchange. There are multiple types of exchange like direct exchange, fan out, or topic. I'll teach you how to create different types of exchange in next videos. Durable, you understood this concept. Message will not be lost if RabbitMQ restarts. We have to bind the queue to the exchange. Email queue is gonna bind to the notification exchange, and this one is the email. So routing key, I think. And then you have to provide the channel.publish notification exchange, and you need to provide the routing key and your message. Producer publish the message to the exchange. Exchange routes using routing key. This one is the routing key. It's an address label. Routing key is like an address, your address label in post office scenario. We create an exchange notification exchange. Each queue is bound with routing key. For example, email. When we publish with email as the routing key, RabbitMQ delivers to the email queue. Why multiple queues? Each microservice gets only relevant messages. Each queue can scale independently. Add or remove queues without touching producer is very easy. Separate retries and let letter handling. Multiple queues helps us decouple services, scale independently, and make the scale flexible. So you have learned exchange. Exchange is like a router that decides where messages go. Routing key is like an address label or label that describes the message type. Binding the rule linking a queue to an exchange. So we're gonna follow this strategy. Producer will send message to the exchange, notification exchange. These messages will be delivered to the email queue, SMS queue, push notification queue. Producer send message to the exchange. Exchange routes messages to the queues using routing keys. Consumers listen on these queues to process tasks independently. Now we're gonna implement this scenario, the Gmail notification feature. Remember, we need to create 3 queues: email queue, SMS queue, and push notification queue. We're gonna do a lot of refactoring. I don't need these producers. I'm gonna create a one producer. One producer will produce, or you can say producers. Actually, what I can do, let me do that. We have to do a lot of refactoring in producer. I'm gonna copy this connection code because we need that. We are going to refactor this, the general consumer, the main consumer, the main producer. Get connection, missing from RabbitMQ, get rid of this producer. Because we will have one producer, will publish the message. I don't need this channel. In the RabbitMQ, we're gonna set the type of the channel so we get the syntax highlighting. Now the type is channel. Now let's write the producer. First one is connection channel, and we need exchange. Exchange. This should be notification exchange. We're gonna create this exchange. It depends on you what exchange you want to create. The name should be anything. Exchange. XEXC. EXC. Exchange. Await channel dot assert exchange. Exchange direct. Durable is equals to true. We create, please, if this changed exchange does not exist, then please create it. This assert exchange is doing that. Next, we need to publish the message. Channel.publish. The name exchange. The routing key. Remember, the routing key is like a address label for our. This one is the email routing key, and I want to send the message. So buffer.from. This should be hello, or you can send the message. Actually, let's say user signed up in the Gmail. User ID. I can say email Jane at gmail.com. Hello world. Not hello world, we need to provide stringify the user in the string, convert JSON to string. To publish the message, we need exchange, we need routing key. For email, let's say I can sent email notification. we're gonna have a same exchange. This time the routing key should be SMS. So whatever queue will have this routing key SMS, he will receive the notification. For push, we will have push notification, push routing key. That is the main role of producer by using the exchange, right? We need to refactor that code. We also, because we need to use the set timeout to add a little bit delay. I'm gonna set into 1500 seconds. Make sure you add the await. Make sure Docker is running. Now our role is to consume the messages here in the consumer. Instead of directly receiving message from the queue, we need to bind our queue with exchange. That is the difference here. Instead of assert queue, I think, yeah, I need assert queue, but here we need to check the exchange. Channel.assert exchange. We should create the name exchange. Should be notification. Make sure you have the same name. Let me get that notification exchange. Channel.assert exchange. Oh, we should provide the exchange. Exchange should be direct and durable should be true. Created the exchange. Now we have checked the assert, get rid of this prefetch, waiting for the queue to. Here the special part is when you are working with exchange, your channel, you have to bind the queue, your queue you created, you have to bind it with the exchange. Durable bind queue will get the exchange. Durable should be bind the queue with exchange. We need to provide the routing key. For routing, I'm gonna use the email and get rid of this one. Everything is same now. We check the exchange, we created or check the queue, and then we bound the queue with exchange by using this routing key. Remember, we are using the routing key while publishing the message. Channel.consume is everything should be same. Now we're gonna test that in the Docker. Make sure RabbitMQ demo is working. I should start the RabbitMQ demo. RabbitMQ. Now it has started. So npx ts node. We need a source file consumers email consumer.ts. Consumer is on the listening mode. Now I'm gonna produce the message npx ts node source. This should be producer.ts. Producer has produced the message. You can see that. Sent email notification, process the email, user, the ID and the email. We are using task.to. This should be content. You can log the content if you want. Email sent. I don't need to do anything here. Let's do that again. Now you should receive the message. Processing email sent undefined. Yeah, because we are not doing anything here. I have to restart the consumer. Send the message again. Now you should see processing email sent. So similarly, we are publishing messages to this routing key SMS and the push, but we do not have consumer. I'm gonna duplicate this, copy and paste it here. This time this should be SMS consumer. This should be copy and duplicate. This should be, I think, email, SMS, and push queue, push notification, push consumer. So instead of email queue, I'm gonna send the SMS queue, notification, routing should be SMS, waiting for SMS. This should be SMS, or I can say SMS sent. My email consumer is running. I should run TS. Let's do the push consumer too. This should be push queue. My routing should be push, waiting for push, push task in the queue, processing, push notification, and I can say push notification sent. That's it. Here we're gonna start SMS consumer. Processing, because we sent 3 messages. When we run the producer, we sent the messages, so that is why it has consumed 3 messages. Next we should start npx ts node source consumers push consumer. I think it will also receive messages because we already sent the messages. So when I run the producer again, all of these consumers will receive the message. This one is email sent, another message received, SMS received, and push notification sent. That is how the exchange work. There are multiple types of exchange: direct exchange, topic exchange, fan out. We're gonna talk more about all of them. There are 4 types of exchange: direct exchange, topic exchange, fan out, and the headers. We have used the direct exchange. Remember, before exchange, I must need to know about the queue, the name of the queue. While producing or sending the message, if I will not use exchange, let's say if I am not using exchange, I have to know exactly the queue name, email queue. What happens if we have 15 queues? I need to remember the 15 queue names. That was the issue. So that problem solved by direct exchange. Instead of remembering the email queue, all you need to remember the label, this one, the email label. Remember, on the consumer side, we're gonna bound our exchange to the queue with this label. This is the routing key. That is the main concept of direct exchange. Why do we need direct exchange? You don't need to remember the queue name. To send the message in direct exchange, you need to remember the routing key, which is label like SMS. If you look up the SMS consumer, you don't need to remember the SMS queue here, right? You only need to remember the label, the routing SMS. Similarly, we use for the push notification. That is the major difference of direct exchange. We're gonna learn more about topic exchange, fan out exchange, and the headers exchange. Now we're gonna talk about topic exchange. First of all, you must need to know why do we need topic exchange. In a direct exchange, messages are routed only by exact routing keys. Here you use this method. Let's say I'm gonna send message to direct logs, and this is the routing key, the label, and this is the message. Any routing key attached to this queue, like this routing key attached to any queue, this queue will receive the message. That message goes only to the queues bound with error routing key. But What if you want flexible matching? Like when you have this type of scenario, order lifecycle methods, like say order created, order cancelled, payment success, payment failed. When you feel like this type of scenarios where you have some type of lifecycle events, then you need topic exchange. Let's say you want the order service to get all the order messages, the payment service to get all the payment related messages, the audit service to get everything. That's why they use the hash. Direct exchange cannot do this easily. It requires multiple bindings and manual key management. That is where topic exchange comes in. This star matches exactly one word, matches zero or more words. This hash means matches zero or more words. Order dot created, order dot cancelled, payment dot success. This is the example. Get all the order events. This one, order dot slash. Get all success events. Get any cancelled event, any admin, any domain, right? It will be triggered. Instead of matching exact words, topic exchange lets you match patterns like wildcard, search, or file globbing. Too many routing keys in direct exchange creates problem. That is why topic exchange can use the pattern matching. In direct exchange, it's hard to manage growing event types. You can subscribe to groups of events easily. Now we're gonna talk about practical example. We're gonna build e-commerce type application, order created, order cancelled. We will have this type of events. Order service cares about order related events. Payment service related care about payment related events. Audit service listen to everything. Let's start implementing the topic exchange. I have removed the consumer folder. Currently this is my minimal setup or starter setup. We have get connection and create channel. Next we're going to create the topic producer. Instead of this producer, I'm going to replace that to topic producer. Topic producer. We are building the e-commerce application. I'll say shop events. Shop events. It's going to create the exchange. Instead of direct to topic, durable true, that would be fine. Next we're going to send the messages. Let's say we receive this type of messages. Key should be, let's say, order dot created. If order created, then we're gonna send the message order created. Similarly, we're gonna have more events. This should be the key order cancelled. Order cancelled. We're gonna have more keys, payment success. Let's say order has been cancelled, then you will publish the message by using this key. I'm using the array for only demo purpose. You can say that payment success. In here I can say payment failed. Payment failed. If payment failed on the front end, you can emit your endpoint can emit the message. Then you call that publish the message by using the RabbitMQ. Payment has been failed. Payment failed. So we created the messages array. Get rid of this user. This time we would like to publish the message. I can use the for loop. I can say for. I can say const. Let's get the key value pair, key and the message. Iterate on messages. Here I can say channel.publish exchange. This should be my key. And this should be my buffer dot. This should be the message. Convert the message in the form of buffer. And finally I can say it should be a simple message, not a message complete. This one, I can log the message sent. Let's use the backtick. Sent, the key name, and the message. And finally we will close the channel and close the connection. Next we will have the order producer, order consumer, order service. It's really order consumer, you can say order service, however you want to call. Let's say order service. I can say order service .ts. This is the consumer. I'm gonna copy the code of consumer and place it here. The queue should be shop. No. Actually, first we need to get the exchange shop events. Then we have to bind the queue with exchange. Channel.assert exchange topic durable to true. Channel.assert queue, we should provide the queue. This should be channel.assert queue order service, and the name of the service durable to true. Here we should bind the queue with exchange. First we need to provide it's gonna give me the queue. I can say queue.queue and then exchange, and then order dot. This is the pattern. When you look at the topic exchange, topic producer, when you call order dot created, order dot cancelled, this will be triggered. This method. And finally I can log the message order service listening to order. I can say order service listening for order dot star events. And finally we should consume the message. I can say received, or I can say order service received the message or the routing key. You can say that message. Let's use the backtick here. Get rid of this one. Message dot content dot to string. Or you can also log routing key, message dot fields dot routing key. And finally we have to acknowledge the message. Next thing, you can, if you want, you can say payment consumer, or you can say payment service. I'm gonna copy the code from order service to payment service. I'm gonna copy that. This time shop events will be fine. Connection, this should give me the instead of creating connection here, we want to use the create channel. It's gonna give me the channel. I should do the same thing here. Const create channel from create channel. This should be RabbitMQ. I think create connection. Oh, let me check that. inside the RabbitMQ create channel. Yeah, create channel from RabbitMQ, and it's gonna give me the channel. Create channel. Now it looks good. For the payment service, we have, it should be payment service. Payment service. It's now the pattern matching is payment dot star. I can say payment service here. I can say payment service listening for payment dot events payment. Here I can say payment service received. That is it. Remember, the audit service will get everything because we are using the hash match 0 or more words. Anything happened, it's gonna log the message in the audit service. Now we should copy everything from payment service to audit service. Audit service.ts. Paste it here. This should be audit service. Audit service. Instead of this, I want to use that pattern. Listen to everything. I can say audit service. Listening for all events. Listening for all events. Here I can say audit service received. The message I can say fields dot message dot. That looks good. Now we have to test that. Make sure Docker is running. Yes, my Docker is running. My RabbitMQ demo, I should start that. It's running. First we need to start the producer or npx ts node. Start the order service. Order service first. I can say source order service. Order service listening for order related events. Next, ts node, npx ts node, and source payment service. Payment service. Payment service listening. Yeah. npx ts node, audit service, source audit service. Audit service listening for all events. Now we're gonna run our producer npx ts node, source, I can say topic producer.ts. Sent order event, order.created, order created, order cancelled event, payment success event, payment failed. In front end, this could be individual, like when user click on something, this event has been emitted. You should see the message. You can see order service received, order cancelled, cancel order event. This one, payment success received, payment failed received, because we are emitting that. We are publishing in topic producer. Payment success, payment failed. And order service, did you notice? It received all events. Order created. This could be your log service, order service. It could be your logging service. Order cancelled, payment success, payment failed. What if I fired again payment dot success message payment success. Now you should see in topic producer, you can see payment success, audit service. Now payment success, failed, and then success. Order created is good. Order cancelled, order created, order created, order cancelled, order created, order cancelled. This one is very useful in topic exchange. Maybe you have a question, when do I need to use the topic exchange? When you have this type of life cycle related events, then you need the topic exchange. You can also, the audit service you can also use for logging purpose. Like if you have used Winston, if you want to log something in your microservice, you can do that with the help of audit service. This one, you can also look for specific events, like any cancelled event, please log that, or failed event, please log that. Next exchange is Fanout Exchange. When, let's say, a new order is created, we would like to send notification to all other services. This could be email service, SMS service, or analytics service. We want to send the notification to all services. But indirect exchange, or we use the manual method. We call this send to email queue, send to SMS queue, send to analytics queue. But there is a method to publish the message once, and all of the queues will received. We use that method, channel.send to queue, email queue, SMS queue. But if you have 50 queues, you have to manually call each queue. That is a problem. That's multiple sends, and it is tightly couples the producer to every consumer queue. Fanout Exchange act like a loudspeaker. Every message it receives is broadcast to all queues bound to it. No routing key needed, right? Imagine a radio station broadcasting on one frequency. Everyone tuned in gets the same message at the same time. So producer, let's say, what problem does it solve? So producer must know all consumer. He must know all of the queues, how many queues are currently present. The solution is producer just sends once to the exchange, then exchange will broadcast this message to all queues that subscribe to the exchange. Adding new subscriber, if you will not use fan out, you have to add new subscriber, you have to add multiple services need the same data. So it is perfect for pub sub pattern, like publisher subscriber pattern, to one to many. One publish once, and let's say multiple consumer are consuming on a real time. It's when to use Fanout Exchange: when you have broadcast event like feature, system update, a new product launch, notification to multiple services, let's say email, SMS, push, analytics. You can use in the form of cache invalidation, update caches across distributed system, pub subsystem like publisher subscriber system, one producer and many consumers on a real time dashboards. Every consumer displays the same update. A global notification is the use case, real time feeds, cache invalidation, system monitoring, microservices integration. We're going to implement this scenario. Order is will be created, and all of these services will receive not. We are going to implement Fanout Exchange. When order is created, we would like to send the notification to email service, SMS service, and analytics service. I'm gonna delete. Actually, we have to need a different exchange. So what I can do, instead of order service, what I can do, I can create a new folder called Fanout. Here I can have order consumer .ts. I'm gonna copy everything from order service to order consumer. This time, instead of shop exchange, this should be a different exchange, order broadcast. Order broadcast. The the exchange type should be fan out. This is the queue. I think I'm working on the order consumer first. Actually, the order is producer. Let's implement its order producer. order producer. Let's say a new order is created. Let's create the fake order. ID should be 123. Product should be MacBook Pro, and the price should be, let's set the price. And here we don't need to worry about the queue when publishing message. Let's call the channel.produce, actually channel.publish. Channel.publish. We need to provide the exchange name. For Fanout, we don't need to provide any of the key, routing key. Buffer.from. This should be json.stringify order. If you are not using Fanout Exchange, you have to channel.publish for exchange, and here you should be a different, let's say SMS key, and here you should use channel.publish exchange, the analytics key. This one should be messy. If you have like 50 queues, you have to run the 50 line of the code. Instead of creating a simple exchange, order broadcast one exchange, any queue that bound to order broadcast, it will receive this notification, this order notification. And finally, I have to copy this code because we need to close the connection and close the channel. It's gonna give me the connection too. Yeah, get rid of this one. Next, we need to create the consumer. Remember, we want to send the notification to email service, SMS service, and update analytics service. Instead the Fanout, I can create the email consumer or email service, however you want to call it, depends on you. Email service or email consumer. I'm gonna copy some of the consumer code here and paste it here. Let's use the same exchange. Wildcard is order producer. From the Fanout, we used the order broadcast. Copy this one and yes, Fanout exchange. Queue should be this time for this. We're gonna create the temporary queue. It will be deleted automatically when message will be consumed. This is the auto delete temporary queue. And channel.bind queue.queue. Yeah, exchange should be, yeah, routing key should be empty. Get rid of this one. Channel.consume. Here I can say the message email consumer received. Email consumer received. I don't need to provide this one, the routing key. All I need to interested in message content. Here you can log the message. Email service waiting for messages. Similarly, we need a same stuff for SMS consumer. SMS consumer, copy this code. This should be Fanout exchange. I can say SMS service, SMS consumer received, SMS service. Yeah, that looks good. Similarly, I should analytics, however you want to do, analytics consumer.ts, paste it. Analytics consumer, analytics consumer. Yeah. npx ts node source order. First we need to run the email consumer. I think there is an issue. I think source fanout. I did not went into the fanout directory. Fanout email consumer. I think my Docker is not running. I have to start the RabbitMQ server. Let's run the consumer. So email consumer is running now. Let's run the SMS consumer fanout SMS consumer.ts. Let's run the analytics consumer fanout analytics consumer.ts. Now I should call the producer npx ts node fanout source fanout order producer. This will broadcast the message to all consumers who has bound to this order broadcast exchange connected to RabbitMQ, and I did not add any message here like message published, but you should see the message. Email consumer received this message, SMS consumer received this message, analytics consumer received this message. This is powerful when you have this type of use case or scenario where you notify multiple services, multiple microservices, or multiple consumers. Then you need Fanout Exchange. To understand the header exchange, this is the last type of exchange in RabbitMQ. To understand header exchange, you must need to first, let's say, understand this use case. We have this type of use case. We need to build that reporting service. A reporting service can provide report in either HTML, PDF, or CSV. You can say generate a report for USA region with PDF format. Or maybe you have a feature generate a report for Asia region. Oh, I have to fix that. Asia region with CSV format, and all high priority reports no matter what the region is. How will you structure with RabbitMQ? Direct Exchange routes messages based on routing keys. Great for known fixed event types like info, error, warning, but limited when you have many routing criteria. Like I want to get report for specific region, I want to get report with high priority, I want to get like this one, the CSV format report. Topic exchange, if you implement the topic exchange routes messages by pattern based on routing, well, this one great for order created, payments failed, but it still depends on the routing key string, meaning you must design your key format in this way. Like QA, you might want, let's say, QA only PDF reports from US, QB only CSV reports from EU, Europe, QC all high priority reports. If you use the topic exchange, your routing keys would like this one, report.pdf.us.high. That would be a lot of complexity. How many combinations are there? Could you imagine that? Report.pdf.asia.high.asia.low.asia.csv, stuff like that. That's messy. Header exchange solves this problem. Header exchange solves this by routing messages using message headers instead of routing keys. Header exchange routes messages based on the key value pair inside the message header, not the routing key. This is the format of header exchange. You bind the queue, PDF reports, header exchange. This one, X match all means all header conditions must match. These are all the conditions must match. X match, any one of the conditions can match. If I add any here, any one condition must match. When to use header exchange? You want to route based on message metadata. This one is important, not routing key. It's a cleaner, more dynamic. You have multiple criteria like region, type, priority, 3 more criteria, then you need the header exchange. If you need multiple criteria, then you need the header exchange. This one is important. Your producer are heterogeneous, different systems, dynamic fields. You need runtime flexibility. It is a practical example, report distribution system. Just like I showed you this one, you have reporting service that generates reports for different formats, PDF, CSV, region, US, EU, Asia, priority is low, high. Different microservices want to process only specific reports. Now we're going to implement this distribution reporting service. Let's create a new folder. I'm going to call it the header exchange or reporting. Yes, that looks good. First, we need report producer. I'm gonna copy everything from Fanout order producer, paste it into here. Now this should be the headers exchange. Instead of exchange, order broadcast to report headers exchange. We have the headers exchange now. Now we need to send the message. I'm gonna send the, let's create the array. I need the data. It should be, let's say, US PDF report or headers. Format should be PDF and region should be US. Region should be US and priority should be high. This time I should get the EU Europe PDF report and format should be CSV report. Yes, CSV report. Format should be CSV. Region is EU. Priority is low. Next, we need to get the low priority CSV. This should be EU. US CSV low. Let's low priority report. Priority report. Did you notice we have multiple values or multiple filtering area or multiple criteria? US CSV low priority, format should be CSV, region EU, US, and priority should be low. And here I'm gonna run the for loop to get all messages, message of messages, and I'm gonna call channel.publish the exchange. We don't need to provide anything for the routing key, and buffer.from, and we're gonna send the message. Message.data, And here we should provide the headers. This one is the crucial message dot headers. So please give me the PDF report with US region and have a high priority. Get rid of this one. That is the concept. That is a complete producer in headers exchange. If you want to add more criteria, let's say criteria 1 something value, you can do that in the header. Next we need to create the consumer. This could be, let's say, PDF reports from US. I'm gonna call it consumer1.ts. Copy any code from consumer and paste it here. This should be, let's add the complete exchange name, report headers exchange, not fan out, it should be headers. And I'll call it Q should be PDF US reports. PDF US reports. Get rid of this one. Now we bound the queue with exchange. While binding the queue, you need to add some configurations like xmatch please match all of the headers criteria. Format should be, this will listen on format PDF and region US. So we are sending in this way. This code, this criteria will call this consumer, this one. Here I can say, because these criteria is matching in the header, this one, format PDF, I can say PDF US service waiting. PDF US service consumer received. Yes. You can also change the name of PDF US service. Next, our next consumer is, I'll call it high priority any region, high priority.ts. Copy the code and paste it here. We have to change the name. It should be high priority reports. High priority reports. High priority reports. Match should be any, like any criteria like this one. It should be matched the region US. And priority should be high. Priority should be high. Because we are passing priority high in this way, in the first object. So this will consumed only for this object. So consumer will call for only this object because this condition has been matched priority high. If you set the priority low, these two conditions will be fulfilled, right? And say priority high service waiting, priority high service consumer received. Next, all CSV reports, any region. This could be for CSV reports. I can say CSV reports for any region. CSV report service, I'm gonna copy high priority and paste it here. It should be CSV reports. Yes, CSV reports. CSV reports. The criteria should be, format should be CSV. Match should be any CSV. For in our case, this will be run this will also be executed. It doesn't matter what priority it doesn't matter what region is. This will work. So I can say CSV service waiting, and here CSV service consumer received. Next, we should run the consumer first. Instead of fan out, I should go to reporting, and I need to start PDF US service. So I think my Docker is paused now. I think I have to resume the Docker. Now you can see connected to RabbitMQ. PDF US service is waiting. Similarly, for reporting, go to the source, reporting, and high priority. This one is also running, and for reporting, this one should be CSV reports.ts. CSV report service is running. Now we should send the message by calling the consumer, npx node source reporting. I'll use the report producer. It's gonna send the message. You can see PDF's US service received the message. US PDF service, priority high service wait, priority high service received the US service because we set the priority high here. And for CSV, I told you 2. So CSV format is 2 condition. This format's object number 2 and object number 3. That is why it has logged 2 times. CSV report run. This is how you use the header exchange when you need multiple criteria, and then you need the header exchange. You don't need to worry about routing key in header exchange. Here you can have multiple criteria.